A few days ago, Elon Musk dropped a prediction on X that was wild enough to shatter Wall Street's imagination. He said SpaceX's market cap will one day break $100 trillion. $100 trillion. That is a 1 followed by 14 zeros. This number is probably so big that it is beyond our intuitive sense. So let's find a reference point. The total global GDP in 2025 is only around $120 trillion. What does that mean? It means what Musk wants to build is not just a big company. It is not even just a business empire that is rare in all of history. The vision he is drawing is a brand new economic entity. Its scale would be comparable to the entire economic output of human civilization today. He is not trying to cut the biggest slice from the existing economic pie. He wants to bake a new pie that is as big as, or even bigger than, the one we have now. This sounds like pure delusion, a grand narrative that belongs in a mental institution, right? But if we strip away all market emotions for a moment, forget stock tickers, forget valuation models, forget Musk's controversial personality, and we only use the coldest physics equations and the most fundamental first principles of economics to reason it through, you will be surprised to find that behind this seemingly absurd number, there is actually a logically tight, almost inevitable path to the future. This path is not drawn in a PowerPoint deck. It is paved by Newton's laws, the laws of thermodynamics, and marginal cost curves. Merry Christmas, everyone. This is Money Stories. Today, we are going to let our imagination run a bit. We are going to daydream about $100 trillion. We are going to talk about what might become the first interstellar sovereign entity in human history. We will throw away the traditional Wall Street analysis framework. Things like price-to-earnings ratios, price-to-book, and discounted cash flow models all fail here. Those models were built to value businesses on Earth. We will start from the limits of physics, the feasibility of engineering, and the deep logic of macroeconomics. We will dig into how SpaceX is trying to evolve from an aerospace manufacturer into a public utility for the entire solar system. It is an astonishing species jump. This is just a thought experiment, but I strongly suggest you listen to the end. The topic itself is fascinating, and in my view, the reasoning gets more and more interesting as we go. I hope it can open a new window in your mind, so that the next time you look up at the stars, you will feel something completely different. Before we dive deep into this mental journey, I want to plant a little Easter egg that is worth a fortune. Did you know that the speed of light is different in different media? In a vacuum, light actually travels 47% faster than it does in optical fiber glass. You might say, so what? For normal people, watching videos or replying to messages, that extra few millionths of a second is less than 1,000th of a blink. It feels meaningless. But for some people on this planet who control enormous capital, that tiny difference of a few milliseconds is the line between life and death. It is a profit window worth tens of billions of dollars. The physics behind this difference is one of the hidden levers that could let SpaceX dominate the future global economy. Why is that? We will talk about it in detail later. For now, let's get started. The first problem we need to solve is a mismatch in perception. Why have today's valuation models already completely failed when it comes to SpaceX? If you follow financial news, you may know that SpaceX is preparing for an IPO in 2026. The target valuation is around $1.5 trillion. $1.5 trillion is already an outlier. In human history, only a handful of companies have ever reached that level. NVIDIA, Apple, Microsoft, Amazon. They all got there after decades of accumulation. They are consumer electronics or software giants with billions of users. SpaceX, at its core, is still doing the work of a mover. It moves stuff into the sky. We need a reference point. Look at the traditional aerospace giants. Boeing, Lockheed Martin. These used to be the crown jewels of industry. They are at the core of the US military-industrial complex. Where do their market caps usually sit? Around $100 billion. At most, $150 billion. They have been stuck in that range for decades, as if locked in an invisible cage. Why? Because their business model is very stable, but also very boring. You could even say rigid. They live off government defense contracts. They sign cost-plus contracts. What is cost-plus? It means no matter how much you spend to build the plane, the government reimburses you. Then it gives you a fixed profit margin, maybe 5 or 10%. Under this model, companies have no incentive to cut costs. In fact, they are tempted to drag projects out and spend more. Their growth is locked to the growth rate of the defense budget, usually low single digits per year, just keeping up with inflation. SpaceX is different, completely different. If you value it at $1.5 trillion, Its price-to-sales ratio is around 90. In finance, what does a 90 times price-to-sales ratio mean? It means the market has gone crazy. Usually only monopoly-like internet software companies, SaaS companies that can write a line of code and sell it to the whole world with almost zero marginal cost, deserve that kind of multiple. Definitely not a company that builds rockets, burns fuel, welds steel plates, and faces explosion risk. Capital markets are full of the sharpest and most ruthless vampires. The reason they are willing to pay this insane premium is because they see through one thing. What everyone is betting on is not rocket launch services. Yes, SpaceX makes good money launching rockets. It has basically monopolized the global commercial launch market. But that revenue, tens of billions or maybe over $100 billion a year, is nowhere near enough to support a $1 trillion valuation. What everyone is really betting on is a hypothesis called Starlink solvency. In simple terms, investors believe SpaceX is using its monopoly in rocket launches to build a global, exclusive infrastructure. They are buying a call option on the future, a future that is uncertain, but can only be realized through SpaceX. They believe SpaceX is becoming the sole gatekeeper of orbital space. You want to go to space. You want to use data from space. You want a slice of this new domain? Sorry, you have to go through SpaceX first and pay a toll. But that is still only 1.5 trillion. There is still a gap of almost 100 times between that and Musk's 100 trillion. What does that mean? Going from 1.5 trillion to 100 trillion is not just a change in quantity, it is a change in kind. It is like going from riding a bicycle to flying a plane. To fill that gap, you cannot just sell broadband on Earth, launch satellites, or send a few billionaires on space tourism trips. That is absolutely not enough. Even if you monopolized all broadband business on Earth, you still would not reach that number. To understand what 100 trillion means, we have to look deep into history. We need to find a template that matches it. In thousands of years of business history, there is only one entity that comes close to this status. The Dutch East India Company in the 17th century, the VOC, on paper, it was a company. It had shareholders. It paid dividends. It was the world's first publicly listed company. But what was it in substance? It had its own army and navy. It could wage war to protect its spice trade. It could mint its own currency and circulate it in its territories. It had the right to sign treaties with sovereign states and carve out spheres of influence. It could even set up courts, try criminals, and carry out executions. It monopolized all trade from the Cape of Good Hope to the Strait of Magellan. It was not just a company. It was a full-fledged quasi-sovereign state. At its peak, if you convert its value into today's purchasing power, it accounted for a huge share of the global economy at the time. Musk's vision is essentially to turn SpaceX into the Dutch East India Company of the solar system. Pay attention to my wording. The solar system? If SpaceX only serves the Earth's economy, if it only helps companies on Earth move things around, then its ceiling is just a slice of Earth's GDP. It would be like a delivery company today. No matter how good business is, it can never be bigger than the e-commerce platforms it serves. But if it can develop resources on the moon, on asteroids, and on Mars, then it is creating incremental economy outside the scope of Earth's statistics. It is not just transporting value. It is creating value only when it becomes the sole channel connecting Earth and off-world resources and extracts value from that channel like a kind of tariff does 100 trillion become mathematically possible. It is no longer a company competing in a market. It becomes the market itself. It becomes the infrastructure. It becomes an interstellar sovereign utility. So what is the first cornerstone that supports this vision, which is so grand it sounds insane? It is not money. It is not policy. It is not Musk's personal charisma. It is not fan enthusiasm. It is physics. In the space economy, every business model, whether you have thought of it or not, lives or dies based on one cold physical variable. The cost of sending 1 kilogram of mass into low Earth orbit, LEO, this is the gravitational constant of the space economy. This number decides everything. If it is too high, everything is just talk. If it drops low enough, miracles happen. For a long time, humanity was locked in by a famous equation, the Tsiolkovsky rocket equation. I am not going to write out a bunch of calculus symbols here, but you need to understand how brutal this equation is. It describes the essence of rocket propulsion. To gain velocity, delta V, you must throw mass out the back to reach the enormous speed needed to enter Earth orbit. The first cosmic velocity is about 7.9 kilometers per second. Add atmospheric drag and gravity losses, and you need about 9.3 kilometers per second of delta V. To do that, the vast majority of a rocket's mass must be fuel. Under the tyranny of this equation, the rocket's mass fraction is extremely harsh. A traditional chemical rocket is more than 90% fuel and oxidizer. A few percent is the rocket's structure, engines, and tanks, the dry mass. What is left for actual payload is usually less than 4% of the total mass. Imagine driving a huge 100-ton truck to deliver goods. To make the trip, the truck carries 96 tons of fuel and only 4 tons of cargo. And the worst part, once this very expensive truck reaches its destination, you have to destroy it or dump it into the sea. How do you make money with that business? That is why in the space shuttle era, even though it was an engineering miracle, the cost of sending 1 kilogram to orbit was still over $50,000. At that cost, only national, no expense, spared research projects, and extremely high-value communication satellites made sense. For example, satellites that could broadcast the Olympics to half the planet. Any other commercial activity was suicide. You want to build a factory in space. Dream on. The shipping cost is 10,000 times higher than the value of the product. You want to build a solar power station in space. That is insane. The electricity would be more expensive than gold. No one could afford it. That is why, for the past 50 years, human spaceflight technology seemed to stagnate. It is not that we did not want to move forward, we were locked in by physics and economics until the Falcon 9 appeared. By vertically landing and reusing the first stage, SpaceX cut the cost down to around $2,700 per kilogram. That is a 1 order of magnitude breakthrough. It allowed many commercial satellite companies to survive. It made projects like Starlink, at least initially, feasible, but that is still not enough. Not even close. At $2,700 per kilogram, it is still too expensive. To build a 100 trillion level economy, we have to completely break the tyranny of the rocket equation. That is the historic significance of Starship. You have probably seen Starship in videos. That shiny silver thing that looks like a stainless steel water tower. Sometimes it blows up in a giant fireball. But do not be fooled by appearances. Starship is not just a bigger rocket. Its core logic is not just reuse. It is full and rapid reuse. Starship's design goal is to operate like a commercial airliner. Think about a Boeing 737 or an Airbus A320. It lands, taxis to the gate, refuels, loads catering, swaps passengers, and can take off again in under an hour. That is real reuse. If we break it down from first principles, and if Starship's technology fully matures, here is what we get. First, it uses liquid oxygen and methane. These are some of the cheapest industrial commodities. The fuel cost for one launch is only about $1 million. Yes, you heard that right. Fueling the largest, tallest rocket in human history might cost less than buying a prime apartment in the very center of a major global city like New York or London. Second, if you include the salaries of the operations team, depreciation of the launch pad, and wear and tear on ground support equipment, the marginal cost per launch could drop below $10 million. How much can Starship carry in one go? Between 100 and 150 tons. Let's do some simple grade school division. $10 million divided by 150,000 kilograms. What is the cost per kilogram? About $66. If in the future they optimize further with in-orbit refueling and ultra-fast turnaround as Musk envisions, the aggressive prediction is that this cost could drop to $10 per kilogram. What does that mean? It means all traditional business logic collapses. It means the cost of sending your Tesla Model 3 into space might be lower than shipping it by sea from the factory in Shanghai to the port of San Francisco. When the cost to orbit falls below $100 per kilogram, the nature of the space economy undergoes a phase change. Just like water turns into steam at 100 degrees. This is a critical point. Business models that were previously rejected as too expensive, like space mining, space tourism, and moving heavy industry into orbit, suddenly cross the break-even line and become profitable. This is the door that physics opens for economics. SpaceX is no longer just a rocket company, it becomes a company that runs elevators out of gravity wells. Besides being cheap, Starship has another huge advantage. It is big. Its payload bay is about 1,000 cubic meters. It is like a giant warehouse in the sky. This enables an interesting engineering innovation that SpaceX calls the Pez dispenser mechanism. Remember those Pez candy dispensers from when you were a kid? You tilt the cartoon head back and a candy pops out. Starship is like that candy dispenser. Because it is so big, it does not need to fold satellites like complex origami to save a bit of space. It can simply spit out satellites like candies. One launch can deploy 60 large satellites into orbit. Each Starlink V3 satellite weighs about 1.9 tons. That means one Starship launch can inject over 100 tons of high-tech infrastructure into space. In the past, launching a satellite weighing a few tons was a national event. With this physics foundation in place, we can finally open the door to 100 trillion. We're going to talk about the 4 pillars that support this empire. Each pillar alone could support a trillion-dollar company. SpaceX wants to own them all. The first pillar is the Starlink we are familiar with, but it is the evolved Starlink that you may never have truly understood. We can call Starlink the Connectivity Singularity. On the road to 100 trillion, Starlink is the first stage booster. It is not only the cash flow cow, it is also the nervous system that lets SpaceX control global information flows. Most people think of Starlink as something that brings internet to rural areas, or something for people living in remote mountains, or a way to give planes and cruise ships Wi-Fi so you can scroll TikTok in the middle of the ocean. That is too small a vision. Starlink's goal is not to be just another ISP on Earth. Its goal is to become Earth's outer brain. The latest V3 Starlink satellites each have a bandwidth capacity of up to 1 terabit per second, that is 1,000 gigabits per second, 10 times more than the current V2 satellites. With Starship, SpaceX can launch once a week. In a year, it can add more than 3,000 terabits per second of capacity to the global network. What does that mean? The total capacity of all submarine cables in 2023 is huge, but Starlink's build-out speed is something terrestrial fiber simply cannot match. Submarine cables need surveying, laying, and maintenance. They get bitten by sharks or snagged by ship anchors. Fixing one can take months. Starlink weaves the network directly in the sky. If one satellite fails, you just replace it. On top of that, Starlink 5.3 uses extremely wide E-band spectrum and advanced beamforming technology. It can focus signal energy, like a spotlight on a stage, targeting very small areas. That means it is highly efficient, it can deliver amazing speeds and connection density without interfering with other signals. So how does such a massive network make enough money to support a multi-trillion valuation? Is it just by charging regular users $100 a month for internet? Of course not. This is where I reveal the puzzle from the beginning. Remember I said light in a vacuum is 47% faster than in fiber? This is called latency arbitrage. Basically, speed of light arbitrage. When we watch videos or movies at home, a few milliseconds faster or slower makes no difference. But in high-frequency trading, HFT, those milliseconds are life and death. Imagine London and New York, the 2 biggest financial centers in the world. Every second, trillions of dollars of trades are happening between them. If the price of gold in New York changes because of breaking news, it takes time for that information to reach London. Today's submarine cables carry light through glass fibers using total internal reflection. The path is winding, and the speed is limited by the refractive index of glass. Light in glass travels at about 200,000 kilometers per second. In a vacuum, it is 300,000 kilometers per second. Starlink satellites are connected by laser inter-satellite links. Once the signal goes up, it travels in a vacuum in a straight line, almost at the universal speed limit. Calculations show that from New York to London, or from Tokyo to Singapore, going through Starlink instead of submarine cables can save about 10 to 20 milliseconds. For high-frequency trading algorithms, 10 milliseconds is an eternity. It is enough time to execute thousands of buy and sell orders before the London market reacts. You lock in risk-free profit? This is called front-running. Those few milliseconds of information privilege are worth tens of billions of dollars. Hedge funds and big banks on Wall Street will gladly pay huge premiums for them. SpaceX does not need to beg them to use the network. SpaceX can charge tolls and even auction off priority by the millisecond. Whoever pays more gets their data through first. This is like cheating with physics. It is a form of overwhelming, out-of-your-league attack. Beyond that, Starlink is building a sovereign data channel that bypasses ground infrastructure. For multinational corporations, data traveling on the ground must pass through national gateways. It faces censorship, interception, and even physical internet shutdowns. In a geopolitical conflict, submarine cables are prime targets to cut. Starlink is in the sky. It is the only global network that does not rely on ground relay stations. For militaries, governments, and large multinationals, this kind of uncontrollable security is priceless. It is strategic redundancy. If we conservatively estimate that Starlink will eventually carry 10% of global data traffic, that includes all planes, ships, remote areas, and data from autonomous vehicles, plus high-value financial and dedicated line services, then its annual revenue could reach $300 to $500 billion. At a high infrastructure multiple of 20 to 30 times earnings, this one business alone could be worth $6 to $10 trillion. That is already more than Apple and Microsoft combined. But this is just the appetizer. It is only the first piece of the 100 trillion puzzle. Information is important, but what is the most fundamental, most greedy, and never satisfied need at the base of human civilization? Energy. As long as human civilization exists, our hunger for energy is infinite. This is the key springboard for SpaceX to go from 10 trillion to 100 trillion. This brings us to the second pillar, space-based solar power, SBSP. Doing solar power on Earth is actually painful. Even if you cover everything with solar panels, there is no sun at night. There is less sun on cloudy days. In winter, the sun is weak, and sunlight has to pass through a thick atmosphere. A lot of energy is absorbed and scattered by water, vapor, and dust. So ground-based solar is an intermittent energy source. You must pair it with expensive batteries or keep fossil fuel plants for peak load. Otherwise, the grid collapses. That is why even though solar panels are cheap now, electricity prices have not fallen that much. In space, especially in geostationary orbit, GEO, it is a solar paradise. There is no atmosphere blocking the sun. Solar irradiance is about 1,360 watts per square meter. That is more than 36% higher than peak levels on the ground. More importantly, a satellite in GEO can see the sun about 99% of the time. There is almost no night, no clouds, no weather. That means a space power station provides baseload power. Like a nuclear plant, it is stable, it does not need storage, and it is inexhaustible. This idea was proposed decades ago by sci-fi writer Isaac Asimov and scientist Peter Glaser. So why has it never been built? Because of that damned rocket equation, it was too expensive. To launch a gigawatt-class space power station, comparable to a large nuclear reactor, you might need several thousand tons of hardware. At past launch costs of tens of thousands of dollars per kilogram, the launch bill alone would be tens of billions. The cost per kilowatt hour would be higher than gold. It could never compete with coal, hydro, or anything on Earth. Starship changes the rules. When launch costs drop to almost negligible levels, remember that $10 per kilogram number, the cost structure of SBSP is completely different. Launch is no longer the main cost, hardware manufacturing is. At that point, the levelized cost of electricity from SBSP could drop below $50 per megawatt hour. That can compete directly with the cheapest natural gas and even nuclear. And it is pure green power with zero emissions. Imagine a future where SpaceX deploys a huge fleet of thousands of power satellites. These satellites unfold solar arrays kilometers long in space. They convert sunlight into microwaves or lasers, then they beam it precisely to receiving antennas on Earth. These receiving stations can be built almost anywhere. You do not need to dig up the ground like a coal mine and wreck the environment. You do not need to worry about radiation leaks like a nuclear plant, whether it is land-scarce Tokyo, or a giant container ship in the middle of the Pacific, or a military base deep in the Sahara, or a disaster zone where the grid has collapsed after an earthquake. As long as you set up a receiving antenna, energy will flow down from the sky. SpaceX becomes the world's largest energy supplier. It is not selling oil, it is selling sunlight. The global energy transition is expected to require more than $100 trillion of investment by 2050. If SpaceX can capture 10% of the global electricity market, given its flexibility and cost advantage, that is not an outrageous assumption. That would be several $1 trillion of annual revenue. Using utility and energy giant valuation logic, this could add $30 to $50 trillion to its market cap. This is true energy hegemony. Whoever controls electricity controls the blood of industry. If you have an engineering mindset, you might be asking a sharp question right now. You might say, this all sounds great, but sending thousands or even tens of thousands of tons into space is huge. Even if Starship is cheap, that is a massive scale. Can Earth's resources support it? And pushing that much mass out of Earth's gravity well is itself a huge energy waste. That is a good question. It means you are starting to think from first principles. This is the craziest, but also the most logically closed-loop step in Musk's roadmap. The third pillar, a lunar industrial base. When Musk talked about the possibility of a 100 trillion market cap, he specifically mentioned a lunar base and a mass driver. That was not a throwaway line. It is a critical piece of the whole plan. The core logic is this. We cannot just build everything on Earth and ship it up. That is the dumb way. We need to build things where gravity is weaker, then throw them down. Earth is a deep gravity well. Its escape velocity is 11.2 kilometers per second. To climb out of Earth, Every kilogram must burn huge amounts of fuel to fight gravity. The moon is different. Lunar gravity is only 1/6 of Earth's. Escape velocity is only 2.4 kilometers per second, and there is no atmosphere. What does that mean? First, launching material from the moon to Earth orbit takes less than 1/20th of the energy needed from Earth. This is gravity arbitrage. We are in the low spot. The moon is higher up. Throwing things down from high to low is going with the flow. Second, since the moon has no atmosphere, we do not even need rockets. We can build a giant electromagnetic launcher. In other words, a mass driver. Think of it as a long maglev track. It does not even need to be that long. A few kilometers is enough. We lay solar panels on the lunar surface to generate electricity. That power drives the launcher. We accelerate packaged cargo to lunar escape velocity and fling it directly toward Earth orbit. In this process, we do not burn a drop of chemical fuel. The only costs are electricity and equipment wear, and solar power is free. Once this system is built, the cost of sending material from the moon to Earth orbit will drop from Starship's $100 per kilogram to almost zero at the margin. And that is not even the best part. The real magic is in situ resource utilization. ISRU. You might think the moon is a barren desert of dust and rocks, but to an industrialist, the moon is covered in treasure. Lunar regolith is rich in silicon, aluminum, iron, titanium, and oxygen. Blue Origin, Jeff Bezos' space company, has a project called Blue Alchemist. It has already shown that you can melt simulated lunar soil with electric current and extract pure silicon, iron, and aluminum. You can then make solar cells and transmission wires. The process does not require any chemical reagents from Earth, and the byproduct is oxygen we can breathe. SpaceX can build fully automated, unmanned factories on the moon. Using cheap lunar resources and solar power, they can manufacture the huge components of space power stations, things like truss, structures, and solar panels. Then they can launch them with a mass driver to Earth orbit for assembly. We only need to ship the most critical chips and control systems from Earth. The remaining 90% of the mass comes from the moon. This is not just about cutting costs, it is about creating new, high-value products. Take ZBLAN, a fluoride glass fiber. If you make it on Earth, gravity causes convection and crystallization problems. Performance is poor. In microgravity in space, its crystal structure can be nearly perfect. Its signal attenuation could be 100 times lower than the best silica fiber on Earth. If you lay submarine cables with this fiber, you can cut the number of repeaters by dozens of times. Total cost drops dramatically. 1 kilogram of this stuff could be worth millions of dollars. It is a god-tier material that can only be made in space. Then there is helium-3, often called the holy grail of fusion. Lunar soil has absorbed helium-3 from the solar wind for billions of years. It is an ideal fusion fuel. When it fuses with deuterium, it produces almost no nasty neutron radiation. It is clean, efficient, and safe. Fusion is not commercially ready yet. But what if it works in the 2040s? There is almost no helium-3 on Earth. The moon is full of it. If commercial fusion breaks through, and SpaceX controls lunar logistics, it becomes the only fuel supplier in the solar system. It will not control oil. It will control the fuel of stars. This offshore economy, or rather off-world heavy industry, could add another $20 to $30 trillion to the valuation. SpaceX will use a kind of dimensionality reduction attack to push high-pollution heavy industry off Earth and into space. Earth will be left for life and ecosystems. The fourth pillar is the operating system that connects everything: orbital computing and point-to-point logistics. Everyone is talking about AI and compute, but as AI models grow exponentially in size, data centers on Earth face two hard physical bottlenecks: power and cooling. Modern AI data centers are power monsters. One data center can consume as much electricity as a mid-sized city. GPUs generate huge amounts of heat. You need massive amounts of water for cooling. Space is a vacuum, so you cannot rely on air convection to carry heat away. But space has a huge advantage. The background temperature is only 2.7 Kelvin, about minus 270 degrees Celsius. If you block direct sunlight and face radiators toward deep space, you can use the Stefan-Boltzmann law to radiate heat very efficiently. Combined with endless solar power, orbital data centers can approach an energy efficiency of 1.0. Almost all electricity goes into computation, not air conditioning. More importantly, an orbital data center is a data haven. It floats above international waters and even beyond them. It is not under the jurisdiction of any single country's data laws, like the EU's GDPR. For companies training AGI, this outside the law attribute is extremely attractive. They can run the boldest experiments and store the most sensitive data there. The Space AI Compute Cluster that Musk has hinted at is essentially the physical vessel of human intelligence. The future super AI might not live in a basement in Silicon Valley. It might be quietly orbiting above us. At the same time, Starship itself can serve as a point-to-point transport system on Earth. It can take off from New York, go into a suborbital trajectory, and land in Shanghai in half an hour. That would completely disrupt long-haul passenger flights and high-value cargo transport. Today's planes take 15 hours. You are numb by the time you land. Starship gets you there in the time it takes to drink a coffee. This faces huge regulatory challenges. For example, sonic booms. They would be much louder than the Concorde supersonic jet. It also faces safety challenges. It must be as safe as an airliner, with accident rates on the order of 1 in a million flights. But for the military, the ability to deliver 100 tons of cargo to any point on Earth within an hour is an unstoppable strategic logistics capability. The value of such defense contracts is immeasurable. Now let's take a deep breath, put these 4 pillars together and look at the whole picture. Starlink. It controls global information flows. It is the nervous system, space power stations. They control global energy supply. They are the blood. The Lunar Base. It controls off-world resources and manufacturing. It is the bones and muscles. Starship. It controls the logistics lifeline between Earth and space. It is the circulatory system. Is this still just a company? It is clearly a new civilizational infrastructure spanning the Earth-Moon system. Like an octopus, it stretches its tentacles into every vital organ that keeps human civilization alive and growing. It is not playing the game, it is designing the game. Now we can return to the original question. Can SpaceX really reach 100 trillion? From a physics perspective, it is entirely possible. Starship really does break the constant that locked us in. It makes all of this feasible in engineering terms. The equations support this conclusion. From an economics perspective, the logic is self-consistent. It is not slicing up the existing Earth pie. It is enlarging the pie by developing solar system resources. It uses energy and matter from beyond Earth to feed back into Earth's economy. But once we push the reasoning this far, we have to face the coldest and hardest barrier. It is not science, it is not engineering, it is politics. This is the weight of the word sovereignty. Think about it. No sovereign state, especially no great power, will sit and watch a private company. A company that, if left unchecked, could become more powerful than a nation. No one will let it control global energy, communications, and logistics. If SpaceX really achieves all this, it will have the ability to cut off any country's internet and electricity. It could even deliver strikes from space. It will have data hegemony, the power to define what is true. That is a fundamental challenge to the modern concept of national sovereignty. The biggest risk SpaceX faces is not rocket explosions. It is not technical bottlenecks. It is antitrust breakups, nationalization, and geopolitical strangling. One day, the US government might say, Elon, thank you for your contribution. But for national security, we are taking over Starlink. Or countries around the world might unite to impose an orbital tax on anything passing through their airspace. SpaceX's future is destined to be a tug-of-war with terrestrial sovereignty. There is also a sword of Damocles hanging over all of humanity. The Kessler syndrome. If war or accidents create too much debris in space, those fragments will fly around like bullets at several kilometers per second. They will smash into other satellites and create more debris. Once this chain reaction starts, low Earth orbit could be locked by countless pieces of high-speed junk. Forget 100 trillion. Humanity might not be able to go to space at all for hundreds of years. Starlink would become scrap metal. Starship would become a target. All these dreams would go to zero in an instant. We would be trapped in Earth's cradle until our resources run out. So what is the final conclusion? The blueprint Musk is drawing is essentially a massive gamble. It is a bet unlike anything in human history. The stake is the future of our entire civilization. He is not betting on a stock price. He is betting that human civilization can cross the threshold from a single planet species to a Type 2 civilization on the Kardashev scale. He is betting that we can overcome short-sightedness and internal conflict, that we can use explosive technological growth to solve resource scarcity. If he wins, SpaceX will no longer be a company in the way we understand companies today. It will become the physical vessel that carries humanity into the interstellar age. It will be that interstellar sovereign entity. By then, the dollar-based system we use today might not even apply. When resources are effectively unlimited, the definitions of economics will have to be rewritten. SpaceX will define the rules of a new era. If he loses, this might become the most expensive and most magnificent fireworks show in human history. It will prove that humanity ultimately cannot escape Earth's gravity. Not the physical gravity, not the gravity of human nature, but whether he wins or loses, living in an era where we can witness such a turning point is a kind of luck, is it not? We are standing on the edge of a cliff. Some people see the abyss, others see the possibility of flight. This is Money Stories. What do you think about this crazy future? Share your thoughts in the comments. See you in the next episode.